Creo que ahora ya viene la parte que más os interesa, más que los discursos, y es poder escuchar a los grandes expertos que tenemos en Europa. En primer lugar, escucharemos al profesor Legius. Supongo que algunos de vosotros habéis oído hablar del síndrome de Legius, que se parece mucho a la NF1. Pues hoy tenemos el placer de tener con nosotros al doctor Legius, que fue el que descubrió este síndrome. Además, es un gran experto, es un gran comunicador y seguro que nos podrá dar un overview sobre la enfermedad que nos trae.
Good morning, everyone. Many people in the audience. It's the idea to show a few things that are new in neurofibromatosis type 1. And after my talk, Professor Garrett Evans from Manchester will talk about what's new in the treatment of neurofibromatosis type 2. I will start with this here. All of you who have young children with neurofibromatosis type 1, they must have seen that in some of them, when you rub the skin, it turns red, but not uniformly red. There might be this white patch. You can see here, this is whiter and this is red. This is called the anemic nevus or nevus anemicus. This is normal in many children with NF1. Only recently this was recognized as being very frequent in children with NF1. And we know you do not have to worry about it. So if you see this, perfectly normal, don't worry about it. It's a sign, just as a capiolé spot. You can see it, but it does not cause any problem. And it's important that we know that this is just a harmless symptom. Here you can see this again. If you rub the skin, or if you wash the child with warm water, the skin turns red, but there might be this white patch here that doesn't turn red, but that's normal, so don't worry about it. This is something else that is not very well known in adults with neurofibromatosis type 1. You can have some types of complications that you never see in children. So caring for adults with NF1 is different from caring for children with NF1. Because the type of complications and the type of problems you can see in children are very different from the type of problems you can see in adults. This is one example of it. So in adults with NF1, you might have a tumor, so a swelling in the intestinal tract, so in the abdomen. And this tumor has a very specific name called gastrointestinal stromal tumor. It is very rare in the general population, but we see this in about 5% of adults with neurofibromatosis type 1. It might cause bleeding in the intestinal tract, or it might cause an obstruction, so that the content of the gut is not able to move forward. We know that in adults with neurofibromatosis type 1, the prognosis of this tumor is very good, is excellent, and is better in individuals with NF1 comparing with people who get the same type of tumor but who do not have neurofibromatosis type 1. So just removing it by surgery is sufficient to cure the tumor. Then there is another type of tumor that we have been interested in recently, and I mean we is a community of researchers and clinicians who work on neurofibromatosis type 1, and it's called an atypical neurofibroma. An atypical neurofibroma is a benign neurofibroma, but a benign neurofibroma that starts to grow in adults. And we know if you leave the tumor for a long period of time, for years and years and years, it has a tendency to maybe become malignant. So it might turn into cancer. We now can recognize these atypical neurofibromas. And when we know that an adult has an atypical neurofibroma, we try to remove it surgically if possible. And by doing this, we prevent that this tumor will become cancer. You can see here one case. This is a scan at this level. So you see the two lungs. This is the liver. And on the ribs here, there is this large tumor. And when we do a PET scan is a specific kind of scan that looks at the activity of the cells in the tumor. And we see that these cells here are more active than all the other cells here in the neighborhood. So this shows that this tumor is growing, actively growing, and then when it's easy to remove, we will have it removed, even if it's still benign and it's not cancer, but we try to prevent it from becoming cancer. So research in mice has been very instrumental, has been very interesting. There are a number of mouse models that are very good models for neurofibromatosis type 1 in humans. And it's of course much more easy to study mice than to study humans. You can keep many mice in a small cage. They don't eat a lot, so they're very cheap. And you can do all kinds of experiments that will teach you a lot. All kinds of experiments that you would not want to do with humans. Right? So for the advance of science, it's very important that researchers have the opportunity to do experiments in animals and in mice. What this group here from the United States, the group from Wade's lab, what they have done, they looked at the growth of neurofibromas in mice that have neurofibromatosis type 1. And they could show that there is a specific cell called the mast cell, and you can see them here. They are colored in blue, that these mast cells, they come from the blood, and they infiltrate into the neurofibroma. And they could show that if they could prevent the mast cells from entering the neurofibroma, if they could paralyze the mast cells, that these neurofibromas in the mice did not grow. And he showed it in this experiment. Here you see the size of the neurofibromas in the mice that were treated with the drug to paralyze the mast cells. And they did not grow. So they remained at the same level as before, except for these two. You know, there are always cases that frames. There is nothing like 100% in science or in medicine. There are always these odd cases. But most of them did not grow. And if you compare this with the mice that were given no drug at all, they were just injected with water, then most of these neurofibromas started to grow. So this was very helpful and very interesting. Therefore, this was the idea to try to see if this works also with humans. Because we know that in neurofibromas, in humans with neurofibromatosis type 1, we see the same mast cells. So the idea was to paralyze these mast cells with the drug and hoping that the tumors would not grow and would shrink. Then the same group here, Wade Platt, they started a large, what we call clinical trial. So they had many people with plexiform neurofibromas. These are the large neurofibromas that you can have anywhere in the body. They had several MRI scans before, so they knew that these neurofibromas were slowly growing. Then they were giving the drug and see if they would keep on growing at the same speed, or if they would slow growing, or even if they would shrink. And they said, we think that it will be a success if they shrink with more than 20% in the volume. And so these are all the measurements in these tumors of the different individuals with neurofibromatosis type 1. And you see that most of these tumors kept on growing, and that only those here in green, they started out with a certain volume, and after 1 year or 2 years they had a smaller volume, 20% less than before. So from this experiment it was clear that in humans it works, but it works only a very little bit. And you have to treat many, many individuals to have only a couple here, 10 or 15%, that show a small decrease in size of the neurofibroma. So this confirmed the idea that these mast cells are important in the growth of neurofibromas, but the effect in a human with the neurofibroma is much smaller than the effect seen in the mouse. That also shows us that it is very important to do this kind of clinical studies to see if we can transfer the knowledge that we gain in the mouse work to the humans. And you still have to do the experiment, you still have to measure it very accurately before you say, okay, we have a new drug. And that's very important. It's also important that there are individuals with neurofibromatosis type 1 that are willing to participate in these kind of studies. Because if nobody wants to do this, then we will never have the data. And there are other trials, so clinical studies that are running at different institutions, and every year there are a couple of publications that say, okay, we have tried in a number of patients, and then they give the number, a specific product, and usually these products have impossible names to remember, like farnesyl transferase inhibitor. But that's not important. The important thing is, does it work? Does it work at a safe dosage? Because if you have to give a very high dosage so that you become sick and get all kinds of side effects, then it's not a good drug. So you need to find a drug that is safe with very few side effects that you can take for a long time, because neurofibromas grow slowly, you have to treat for a long time, and you have to see a good effect. And this drug was tested in a large group and was said, okay, it doesn't work. That's important. knowing that things don't work, that people are not taking something that doesn't work, so that they have only side effects. We have been working in collaboration with a number of other groups also on trying to find out why these malignant tumors, these cancers of the nerves, why they are so difficult to treat. And the first thing, of course, is to better understand what goes wrong in these tumors. We recently could publish our findings in a journal where we discovered a different mechanism that is responsible in a number of malignant tumors for their growth. And to make a long story short, in most of our cells, many genes are in fact sleeping because they don't have to be active. And there is a specific mechanism that puts these genes to sleep. We have found that in a number of cancers from patients with neurofibromatosis type 1, these genes have become awake. And we now know how we can put them again to sleep. We have shown in mice, that if you put these genes again to sleep, that the tumors shrink. So this gives us again new ideas how we can try to use this in humans with neurofibromatosis and who have cancer. We will try to see if we use these drugs that can put these genes again to sleep, if this also works in humans. But that's a story for another moment, because we don't know it yet. Then there is a study going on that is not yet finished, where they use a specific product from a category that is called MEK inhibitors. It doesn't matter what it means, MEK inhibitor, but it is also something that is some activity that's going on in benign neurofibromas, some overactivity that can be blocked with a certain drug from the group MEK inhibitors. The first results have been shown at meetings already at scientific meetings. They have not been published, but we have seen already some results, and they show that certain neurofibromas that are actively growing can be stopped. The growth can be stopped. They even shrink a little bit, but at the dosage, the effective dosage also causes a lot of toxicity. So people become sick. So you have healthy individuals, neurofibromatosis type 1. They are healthy, but they have a growing neurofibroma. You treat the neurofibroma and they become sick. It shows that you can make a neurofibroma, you can stop the growth, but we have not found a drug yet that is very effective and does not cause side effects. But you see, we are making progress. One day we will be there. This is another interesting study where many, especially adults here, between 20 and 50 years old, were scanned. Their whole body was scanned, and then the volumes of the neurofibromas were measured. And as you can see, there are many people with neurofibromatosis who do not have a lot of neurofibromas internally in their body. And then there are some that have very large neurofibromas, and then these people were followed. And then we know that people who have many internal neurofibromas have somewhat a higher risk that one of these neurofibromas someday might become cancer. So these are the people that we have to follow where we have to look at these internal neurofibromas, and as soon as they start to change a little bit, and we think that they might be atypical or on the way of becoming malignant, we have to remove them. And then, because there are so many people here in the audience, all adults, I always tell the story of the glomus tumors of the fingertips. This is not new, but it is new to many people with neurofibromatosis. A glomus tumor is a small tumor at the tip of the fingers. It hurts very, very much, and you don't see it. That's the problem. Many people go to a doctor, they look at the hand and they say there's nothing to see. I don't know what you have. They take a scan, there is nothing to see. And people have pain and pain and pain. It gets worse and worse. And it's usually worse in the winter when it's cold. In the summer it's a little bit better. But when they hit the edge of the table, it can hurt so much that they have to sit down. We know that these tumors exist in adults with neurofibromatosis type 1. There are so many people here, so there must be at least a couple of people here who have this problem. It's a simple problem to treat. You can have it removed under local anesthesia by a hand surgeon, and then you're cured, and the pain is gone. The problem is that in individuals with neurofibromatosis type 1, more than one finger might become affected during life. So when we have treated one patient, one finger, sometimes they come back 2 or 3 years later and say, "Doctor, I have it now on my other hand, on this finger. Exactly the same, I know what it is, I recognize it, please have it removed." We can cure them. But this is something that we don't know for a long time yet. Only a couple of years ago, this association became known, and there are still many, many doctors that don't know that this problem can exist in individuals with neurofibromatosis type 1. And some of these patients, they have this for many, many years. One patient came to my office and said, "Doctor, I have this for many, many years. If you cannot help me, I will have my finger amputated." Because it was such a big problem. Of course, I have photos of fingers where you do see something. But remember that most of the time you don't see anything at all. You can see the tumor here, but it becomes very, very big, and it has an effect on the nail. So you have an abnormal nail here. You can have a split nail. The tumor is here, and there is a split nail. And here you can also see that there is this little tumor. But sometimes it's only this small red spot. And most of the time you don't see anything at all. But knowing that it exists, if you have it, go to your doctor and say, "Doctor, I have a glomus tumor on my finger, please help me." And if they don't know it, tell them to send an email to me and I will explain them what it is. How am I doing regarding the time, Garrett?
I think you're fine. Mine will be shorter, so you're fine.
Another thing that is much more important for children with neurofibromatosis type 1 are the learning problems. And we know for a very long time that children have learning problems at school. And here also a lot of work has been done in mice. If you have a mouse with neurofibromatosis type 1, then this mouse also will show certain problems with learning. You can teach mice all kinds of different things so that they have to solve problems. And on average, these mice with neurofibromatosis type 1, it takes a little longer to learn something, and then if you don't practice enough, they will forget it again. If you compare with the mice that don't have neurofibromatosis type 1, but they can learn it. They can learn it, but it takes long. It's very similar to what we see in children with neurofibromatosis type 1. They are smart, they can learn a lot of things, but it just takes long. It's exactly the same in mice, even in flies, in fruit flies with neurofibromatosis type 1. It takes them longer to learn something. I'm not going to explain how you can learn flies to do all kinds of things, but believe me, you can teach flies to do all kinds of things. And it takes them longer to learn it, even in flies. Meaning that the neurofibromin, the protein that is made by the neurofibromatosis type 1 gene, is an important protein for learning. It's important in the brain, even in flies. Right? But it's not that important so that you cannot learn anything at all. You can learn everything, but it takes long. And what has been shown in these mice is that you have adult mice, and you treat them with a certain drug, they learn normal. So it's not something that you're born with and is irreversible. It is reversible. You have mice that have a problem with learning, you treat them with the drug and they learn normal. One of the drugs that have been used was lovastatin. And lovastatin is a drug from the group of drugs that is used to lower cholesterol. Many people take cholesterol-lowering drugs. It is a big hit for the pharmaceutical industry because they tell you that you have too much cholesterol in your blood and you have to take a drug. Everybody who is 50 years or older goes to the doctor, they're taking blood, and everyone's cholesterol is too high because they put a limit, what is normal, always lower and lower and lower, so everybody has a cholesterol that's too high, so you have to take drugs. Millions and millions of people take these drugs every day for years and years, and it's safe. So we have a safe drug, and that safe drug is used in mouse with neurofibromatosis, and if you use it, the mouse can learn better. So why not using it in humans? Of course. Then this trial was set up in Rotterdam, in the Netherlands. And you might recognize here the first author of this publication. In Dutch we say Thijs van der Vaart. Don't try to do this if you're not Dutch speaking, because it's very difficult to say. And he had the idea together with the people here from the institution where he is working. Why wouldn't we try to use this statin in humans? Now, lovastatin is not on the market in Europe, but we have simvastatin. So he used simvastatin in a large group of children. But of course you always need more and more and more children to have a large group to see a difference between those that take the drug and those that don't take the drug. And since I'm from Belgium, we speak the same language as in the Netherlands. We speak Dutch, that's why I can pronounce his name properly. We also asked our patients to participate in this trial. The problem is that in this trial, we did not see any difference in learning between the children who are taking the drug and the children who are also taking a pill, but an empty pill. So we just compared two groups. They were all taking pills, but some had the active product and the others had a kind of a sugar pill with nothing. But they didn't know. We didn't know. So we measured them, and then we didn't find any difference. So in the doses that is safe in humans, you do not see the effect. Other experiments have shown that if you increase the dosage 10 times, you give it for a very short period to a person with neurofibromatosis, you see some changes in the brain, an improvement in the function of the brain that you also see in the mice. But you cannot use a dosage that's 10 times higher than what is safe, because then you get all kinds of trouble. If you take that for a long period of time, then it's better to learn a little bit slower than to have all kinds of problems taking the drug. And now in the same lab in Rotterdam, they have discovered that if you treat mice with another product, they also learn better. And this product is called lamotrigine, which is a product that's also used to treat epilepsy and depression. So we will now do the same study in these children and see if they learn better with lamotrigine versus an empty pill. So this is everything I had to say, and I'm happy to take questions if you have. Thank you.